going to talk about inscribed angles. Inscribed angles are angles in which the vertex of the angle is on the circle. Two chords make up the sides of the angle, and the arc that is caught is called the intercepted arc. Now, there's a few important facts here, a few important facts that I'm going to give you. There's 4 of them. There's this theorem. The theorem says that the measure of the inscribed angle, which is angle B, is going to equal 1/2 the measure of the intercepted arc. So the angle, this angle, is going to be half of the arc. So if the arc is 50 degrees, the inscribed angle is going to be 25 degrees. Now, a few corollaries that follow. So here's a circle, and if you need to pause and slow down, you go ahead and do that. We've got an inscribed angle. I'm going to call that angle 1, and it is catching this intercepted arc. So this is the arc that the angle catches. I like to say that. And then I've got another angle here. Let me use a straight edge. Yeah, see, not so good with a straight edge right there. So now I've got angle 2 catches the same arc. That means that angle 1 and angle 2 are congruent. So here's angle 1. It catches this arc. Here's angle 2. It catches the same arc. Therefore, if two inscribed angles share the same intercepted arc, the angles are congruent, which is common sense, which is what some of you are thinking. So you're good. That was a good thought. Then angle 1 is congruent to angle 2. But now we're saying it this way. If you see it, you don't have to think about it. Okay, next one. If, I'm going to use my circle tool again. So I got a circle there, and I'm going to draw a diameter. So my diameter goes through the center of the circle. If, and let's call this M, and the center I'll call O, and then that point is N, and I'm going to put this angle X right here. So if my angle intercepts an arc that is connected to the diameter, then angle X has to equal 90 degrees. Okay. So if, this is a diameter, so if your angle catches a semicircle, then the angle is 90 degrees. Again, another one that's common sense. And here's another one that's kind of common sense, but you might have to prove it. You don't have to prove it. So I don't even want you thinking about it. Here's 4 points. 1, 2, and we'll make that one there, and we're going to make this one here. There we go. So it's going to look all cattywampus. I like that word, cattywampus. This is a quadrilateral. And I specifically drew it so that it was not going to be a special quadrilateral. This is just a 4-sided figure. And we're going to call this E, and this F, and this G, and this H. If you have a quadrilateral that is inside this circle, Then angle E and angle G are supplementary, so opposite angles are supplementary. And E and G are not the only opposite angles. Angle F and angle H are supplementary. So that's kind of a cool thing right there. So I'm going to show you the problems that we're going to work on with these fun facts that I've given you about inscribed angles. So we're going to work on these 6 problems, and then we've got another 7 problems. So we'll work on those 13 problems in